Okay, so let's kick it off this. Well, as I said, my name is Eduardo Silva. I'm the creator of this technology that is called Fluent Bit, and Fluent Bit was born from Fluent D. I was part of the original Fluent D team. And nowadays, I'm a co-founder and CEO at Calyptia, which is, you can call it a data pipelines company, and we're solving these problems of moving data at scale with processing for the enterprise at very different levels. And I have been a CNCF and Linux Foundation friend from many, many years. Actually, it has been around CNCF since the beginning, pretty much, well, same time that Kubernetes was released by Google. And when you talk about data pipelines, we don't talk about just how to process data or move data. Actually, always we think that the higher value to have a data pipeline is because you want to perform data analysis, right? And when you say, I want to perform data analysis for my application, from my services or service level applications, you start thinking about where you're going to start that data to perform that analysis. And you might rely on Datadog, Splunk, Elastic, or many other vendors. And in reality, companies use more than one vendor for different needs. But in the other side, when you got ton of problems where data is being generated from different formats, different sources, and you want to have a seamlessly experience, things get really complex. Data formats, vendors, and performance, right? So every year, companies generate 20 to 30% more data. So how do you make sure that you have the right strategy to move data at scale without disruption, but making sure that you still can obtain or get more value from your backend experience with your own vendor? And this is Calyptia. And Calyptia Core is our flagship product that takes all the Fluent ecosystem for data pipelines to the next level. So Calyptia Core is an observability platform that focuses on the pipeline perspective that allows you to implement a vendor agnostic solution to collect, transform, enrich, and route data to multiple destinations. And not just that, we went beyond that, and now we can do fleet management and control all the agents that sits on your remote VMs, your remote bare metal machines, where you need to collect this data. You might find that we're going to show in this webinar is a real cool technology. But when you go to the enterprise and you want to scale up this technology for the company needs, where you're running 100,000 VMs, right? Managing data pipelines in a Unix file gets really complex. Forecasting how much data you need to process and make and prepare your engineering team for that takes a lot of time. And this is where Calyptia Core comes in as a solution built on top of Fluent Bit that allows you to seamlessly scale, process data with a nice UI, with a very drag drop experience when composing data pipelines. Now, let's get started. We're going, as I said at the beginning, we're going to split in two parts. The first one will be login challenges introduction, and then we're going to jump into Fluent Bit and the series of Fluent Bit and why you should move from 1.9 to version 2, or if you are just getting started with Fluent Bit, you should start with version 2 right away. Everything starts with challenges. As I said at the beginning, nobody wake up in the morning and said, oh, I'm so happy, I want to just manage data pipelines. It doesn't happen like that. It's that maybe you wake up in the morning and you say, oh, I need to extract and collect and analyze this information. And then you start working backwards on what needs to be done to accomplish that. And for the end user, this is data analysis, right? And you need to collect information from services and applications, because most of applications prints a lot of information in a log format. And this log format tells you about information, status from the application, of what's going on. And if something fails, the first question is, not question, first ask, hey, where are the logs? I need more logs. Where is this information? But if you are in today's architecture, where you have applications spread, I don't know, dozen or hundred of servers, that's really hard. We're not longer in an era where we used to SSH into a machine to extract information. It's not longer like that. We need a different perspective so we can scale as much as we data scale. And when we think about just logs, right, that we're going to focus on that specific telemetry data. For example, if you look at the Nginx logs, Nginx logs contains an IP address, a timestamp, and then all the information about the protocol request that was received. But if you go to analyze syslog messages, you might understand, oh, there's a timestamp, or it was a BGP protocol, and then you get the message of what was happening with that service at that moment, right? And you might notice that both things has some similar things. Both are in a file, both has a timestamp. But when you go to Windows event logs, right? I know that nobody likes to play with Windows, but Windows is around. All companies use Windows servers, and you have Windows machines everywhere. And you need to collect information, even from security logs, audit logs, or to understand what's happening inside that box. And Windows event logs has its own uniqueness on how the data is structured and the way to collect it. It's really hard. So when you think about logging challenges, here we have two different environments, two different operating systems, and then you have three services, but all of them in different formats. And now, if we talk about location, on how to extract this information, you might say, oh, all my logs are in var log system. Yeah, but if you want to extract, for example, the kernel log, the Linux kernel, well, you can type the message or just go to the source of truth, which is the key message virtual device, right? But also you might want to extract information for serial interfaces. We're not talking just about cloud. We're talking from very maybe constrained environments to big machine, big server with a couple of dozen CPU cores. Also, the information where it can be collected. For example, we talk about logs, but now there are services that expose you information. For example, if you want to collect data from systemd through the journald, which is journal who store all the login information, you might want to start playing with the API. Sometimes the CLI of systemd is not enough to collect and process the information that you need. Sometimes there's so much information that performance could be an issue when using those type of mechanisms, right? And if you want to collect the data from Windows, it's the same thing. You have to connect to an API. You don't want to go and just open the native files that the Windows event logs is managing on the file system, neither for systemd, because it's a binary format. It has its own logic. Rotation is happening behind the scenes. It gets really complex. But also your data comes from remote endpoints, right? And these are network endpoints where maybe you have a syslog receiver in your machine, or you have an HTTP endpoint where you're receiving logs or certain events that you want to store to further analyze later. And if you're in a Kubernetes environment and you want to extract Kubernetes events, you're not going to receive those events. You have to go open a TCP connection, go to the HTTP endpoint that exposes those events so you can extract them. So logs are everywhere, and the way to consume it and process them are very different. But as I said, all the goal of this is perform data analysis. But when you start thinking backwards, right? Hey, how do I do this properly? You might walk away because you have lots of different operating systems, different services, different formats, and data analysis gets a bit complex. And you start saying, hey, we might do it later. Or I'm just going to write a script, right? You wake up one morning and you will say, oh, I'm going to collect this information in a way that is get really easy through a Python script, a Rust. But then you start dealing with different formats, different sources, same as described in the previous slide. And then when you want to send this information to a network endpoint, because you want to collect them, you might start facing, oh, I have to deal with network, with TLS, with certificates, and network fails, so you have to retry. And then if you retry too much, you got buffering problems and your data is not flowing. So sometimes writing just a simple script or your own custom tool is not scalable over time. So if you think like, I need a strategy, you need a strategy that works over time for a couple of years, not just for the immediate need. You just have one application, that's fine. But in reality, this is what happens to everybody. And as I said, the data comes in different formats. And when I say format or structure, right, it's a way to say, how do I interpret the data? and where is the data points that exist that I need to focus on. If we take a look at the first example here, yeah, this is just a text, right? An IP address, a timestamp, and the HTTP request. But in our minds, since we are used to take a look at this information, we understand, oh, this is an IP address, this is a request time, this is a HTTP method, and so on. Mentally, you have self-trained to understand this. But if you want to do data analysis with a computer, you cannot use the same approach today. Maybe AI will do it in a short future. And you need to go through a way where this data needs to be processed, where we do some kind of cleaning up and we associate concepts with values, right? So we have a key that is called IP address with a value with the address. We will have a request time with a timestamp, and so on for each one of them. I'm using a structured version in JSON just for purpose examples, but ideally, when we're collecting data, we want to finalize in a structure that then we can simplify the processing for it. Okay, and this is one of the challenges that exist. And from a global perspective, you want to transform always unstructured data with a structured format, same as here. But in order to do that, in the middle, there's a process that needs to happen, and this is parsing. And parsing sometimes is part of just processing. And now when you face the reality, where you have not just a single machine, you have containers, you have information coming from firewalls and virtual machines and so on. If you take a very rustic approach, you might end up as this frame that is in the screen right now, where you might customize or create a solution that you think that works. And then you start sending this data for analysis to your very fancy vendor database, which sometimes is really expensive. And if you're using Splunk, you will know, for example, that there is a cost involved. The more data that you ingest to Splunk or any other database is pay as you go, right? The most you ingest, the more you pay, right? And that is a problem, right? You have more data from one side, you have your costs going up from the other side. How do you approach this problem in a very efficient way that you can take the most in a positive way from that solution that you bought that is really good for you, but also making sure that your cost doesn't go up like crazy. And in these logging challenges, just a quick recap, we have different sources, file system devices, network endpoints, and we have different formats to deal with it. And also the data volume is a factor that gets things really, really messy, unless you have the right strategy. And this is where Fluent Bit comes in. Fluent Bit is a solution that I created at the end, I think, 2014. It's written in C language and was written in order to be very lightweight, but high performance, right? I always do this example that it's not about how fast your car can go, but it's always to be conscious of how much gas or gasoline you need to achieve that speed, right? Everybody can say, oh, we need to process these amounts of information. Okay, but how much CPU power you need for that? The more power you need, you might need to scale up horizontally. And maybe your costs are gonna go up. And hard multiple machine is really expensive. And going back to Fluent Bit, well, fully pluggable architecture is a really good and solid runtime with more than 100 plugins that powers and integrates a different type of sources. It allows you to enrich and transfer the data and also connect to multiple destinations. As of today, I would say that all the use cases in the market are solved. Either a custom HTTP endpoint over TCP, UDP, file system, systemd, Windows event logs, there are many. And Fluent Bit is cross-platform. It works on Linux, Windows, macOS, and any kind of BSD variant. And it's highly customizable. It's not just about what features you have in order to collect and move data around, but also how much you can extend or bring your own business logic into the pipeline. So Fluent Bit has been built with all this concept in mind. And the best part of this is a vendor neutral solution. Yes, Calyptia is a primary sponsor, and we have a couple of maintainers working in Fluent Bit. But while back in the year, while back when we created this project, it was donated to the CNCF. And today, FluentD and Fluent Bit are both a graduated project with the CNCF. They will be around for many, many, many years, and there are many companies contributing to it. Right? So just to give you a perspective, you might hear about FluentD, and FluentBit is the next generation of this project. We are part of the foundation, and we are fully committed to make sure that you get your best experience. FluentD is also running for many, many other years, but to be honest, most of the new things around performance and new integrations, telemetry data, most of those investments are in FluentBit. And you might see that Microsoft, Google, and AWS already moved from FluentD to FluentBit. Just deploy a Kubernetes cluster in GKE, and you will find that FluentBit is there. And in our vision as a project, I'm going to put my open source hat right now. It's like we believe in open source observability in a way that there's no vendor lock-in, and in a way that we are not a drop-in replacement for other projects around. Actually, we integrate with them. We always have this philosophy that comes from FluentD of just plug and play, not be a drop-in replacement. I think that drop-in replacement doesn't add value. Actually, I think that it adds more friction to our users, and infrastructure is not a game, it's a serious thing. Infrastructure cannot be down, telemetry agents cannot be down. And we are fully platform agnostic. If you want to have a global overview of FluentBit, what it does, connect multiple sources, multiple destinations, and a lot of magic happens in the middle. Okay, I know that some of you are new to FluentBit, and some of you are still using FluentBit 1.9 series, right? But as you know, when times evolves, there are new challenges. And this is the fun part. There are always new challenges to solve. Every year, there's more data volume, and we want to make sure that our telemetry agent can be able to solve our users' needs. So for today workloads, I mean how much data is being generated, right? FluentBit 1.9 might struggle a little bit, right? Also, when working with cloud-native technologies, you might find that most of the configuration formats and tooling around to validate configuration, everything is YAML, right? And FluentBit used to have its own configuration mode. Also, if you're deploying in containers and you want to apply a new configuration, the old way to solve this was to just restart the container, kill the pod and restart the pod with a new config map. And that was really expensive if you are running in a huge Kubernetes cluster, and expensive in time because it takes some time. And also, it's not the best experience. And also, you know that FluentD and FluentBit originally was created to manage logs telemetry data. But internally, we always has been very agnostic from the data that we are moving and we are using. So we move and we pivot the project to be a real unified solution for logs, metrics, and traces, plus any other telemetry data that comes in. Okay, and also there are new protocol standards that are coming. Open Telemetry protocol. So this is really important. If the industry want to standardize in Open Telemetry, we want that Fluent Bits deliver the best Open Telemetry experience available in performance and in integrations, plus many others. So there's a good and strong reason to move to the newer version of Fluent Bit. If 1.9 is working for you, that's great. But note that as maintainers, we are not longer supporting 1.9 in terms of security fixes or so on. Actually, the upstream version has a very short period of time in terms to receive security updates. So here we are. We are getting to Fluent Bit version 2. And this has been a massive architecture and exciting change for the team. And let me go back and tell you a bit of story. The project started in 2014 with a little Git in it, right? And between back and forth, actually between 2014 and 16, the project was created. We were assembled the first plugins, the architecture, but it was not designed for the cloud. Actually, it was designed for embedded Linux environments originally. And that's why it has a mindset of low memory usage, low CPU usage, but high throughput, high performance. And with all this pivot to the cloud native solution, since Kubernetes was out, Fluent was donated to the CNCF. Fluent Bit joined the CNCF too. We implemented file readers in 2016. We didn't have that. And also we implemented the first experimental output plugins that can be written in Golang. Why? Fluent Bit is written in C. So we implement a full layer where you can plug and play you can plug your own Golang plugins. In 2017, we started implementing more features to have parity with Fluentd and deliver a better experience, like Kubernetes filters. And also in 2017, we got the first Fluent Bit container image. In the next year after, we added Lua scripting because people wanted to have a way to bring the business logic into the pipeline. And I think that it was very connected to GDPR in Europe, which actually the story is like Lua scripting born from a conversation that we got with a lot of users in a KubeCon in Europe around that year. And in 2018, we started seeing the traction of Fluent Bit in the container space. That year, we closed the year with 19 million in Docker Hub downloads. In 2019, Fluentd and FluentBit both graduated from the CNCF. In the CNCF, you have different stages for the project, like a sandbox, incubation, and graduation. Most of the projects join who establish projects joins in an incubation state as Fluentd, and then they are there for some time. For us, it was 2-3 years to get in a graduation status. What means graduation? That many companies contribute to the project. So I don't know, if a bus hits Eduardo, the project will continue because there are developers everywhere. And there's a lot of market interest in the companies also to contribute back to the project. And AWS did their first contribution to Fluent Bit. And there's a funny story about how this started, but I think we were in Seattle or Vegas with Wesley from AWS. They were creating their first Golang plugins. So it starts to see how things connect. They created the Golang plugins. They were really good, but they wanted to have even more performance. So we worked together, and most of Wesley and his team migrated the Golang plugins to C, and then we shipped our Fluent Bit fully with full support for AWS. And as you can notice, at the end of that year, we went from 19 million to 62 million pulls. And then, the rest is story, right? We implemented on 2021 metrics telemetry data type. Support in 22, we were beyond that with tracing, Open Telemetry output, metrics with Open Telemetry, Wasm filters, Golang, YAML, and many things. And this year, we have been working on more kind of high-level features like hot reload, the ability to convert from log to metrics, the new interface to configure Fluent Bit by using YAML, and the Open Telemetry input plugin. Right? We're going to talk more about that in the next slides. And from an architectural perspective, how the project has been evolved is like in 2014, the first design is single thread, fully event-driven with coroutine support, right? But back to 2020 and 22, we just implemented full threading mechanisms, which I'm going to explain now. Okay, when you're thinking on a pipeline, you're just thinking that there's an input, there's something happening in the middle, and there's an output or destination. The changes that happens for us, what we did to happen in the project was like everything used to happen in a single thread. Now there is a concept about divide and conquer. We applied the same concept. Initially, we apply this divide and conquer strategy for output plugins where they run in a separate thread. What that means that the workload on that thread works independently between converting data format into JSON, delivering to the endpoint, while the engine was just synchronizing events and making sure that everything was running smoothly. But the input plugins were tied together. And now with a fully new multi-thread support, your input plugins and your output can run in separate threads. That means that they will run in different CPU cores if the kernel allows it. And then you will have a better experience where performance will be even higher. And also implemented this concept of processors, which I'm going to explain now. In this old mechanism here, where we have the engine was taking care of doing filtering and data enrichment, plus doing scheduling and routing in general. But you might find that if all filtering is happening here in the main thread, it can become your next bottleneck. And that's what happened for many cloud providers. Hey, we are touching 20 filters and it's getting slower. Yes, because we are saturating the main event loop. And the way to solve that problem was implement the concept of processors, which I'm going to explain, where we can defer the filters and be attached to the input plugins, output plugins. And if you're using multi-threading, they will run on separate threads, so scalability is even better. Okay, so let's talk about configuration for a little bit. In the left, we have what we call the classic configuration. Fluent Bit used to have this concept of, hey, we have a configuration that is called a section, that is called a service. Then we have something that is called components for the pipeline. For example, the input, we can have many inputs to define where the data is being collected from by using the built-in functionality, the same plugin, TEL in this example, with a tag and saying, hey, where this data was coming from and what type of parsing we're going to apply. And then we used to define the output, right? Where this data is going from, going out. Well, we have all the concept of routing. I didn't want to add multiple input and output just to simplify the concepts of configuration. Now, with a new YAML configuration format, we try to follow a similar logic, but now you might find that, hey, this is just inside a pipeline concept, right? A pipeline list where we have inputs, outputs. I didn't add the filters here, but the good thing is that, yeah, you have the same concepts and both configurations are compatible together. This is really important because many people say, oh, configurations are going to have breaking changes. No, the YAML configuration are the same concepts plus extra features that I'm going to explain now. But if you want to continue using classic configuration, that's fine. So if you want to migrate from 1.9 to version 2, yeah, it should work. Maybe you might face some breaking changes on functionalities on a specific plugin. Example, oh, we just deprecated a configuration property. It's not longer there. But it should be fine if you move to YAML. I think that moving to YAML won't be an issue. The YAML will be to move between one version and the other and potential breaking changes, which there are just a very few ones, which we always notify the community that those are happening when it happens. Monitoring. When deploying a pipeline, we get a lot of feedback from our users that was, hey, your monitoring experience works, but it's not ideal. And let me tell you why. We used to ship pipeline metrics and separate it in a separate instance the storage metrics. And so having multiple endpoints to monitor the agent, well, you don't have one. Usually you will have, I don't know, if you have 10 VMs, you're monitoring 10 of them. You don't want your Prometheus scraper just, multiple endpoints to the same agent. You would like to have more unified experience. Plus, those metrics were not routable. For example, some users wanted to send those metrics over remote write or over a different metrics protocol, but that was not possible. So with the introduction of Fluent Bit 2, we didn't deprecate V1, but we extended and we added the new V2 endpoint, and we have a new metrics generator. It's a totally new mechanisms that allows you also to route the metrics. For example, if you don't want that your metrics be scraped from our own endpoint, you just can add the metric as part of the pipeline and send them to a different destination, which can speak Open Telemetry, Prometheus Remote Write, Splunk, or Influx, or any type of database metrics that we support. And all these metrics are available now in one endpoint in Prometheus format, text format. So now you can do whatever you want with it. If you want to scrape it in text format, or if you want to route it by using remote write, yeah, that is also a solution. When deploying a container and for operators, sometimes most of application just run, sometimes they crash it, they get restarted. It's not a big issue. But when you deploy Fluent Bit as a container that in Kubernetes behaves as a daemon set, that means that this container runs on every single node of your cluster, and you want to apply a very small configuration change, right? That means, deploy the config map and do a reload of all the agents of the daemon set that has been deployed. And that takes time. That takes time where you are not noticing changes on the files, and it was not a good experience for users. So in V2, we implemented hot reload support. And hot reload support allow us to do changes to the agent, signal the agent that, hey, there's a new configuration available, and the agent is going to restart with the new changes by having a seamlessly experience. And the way to trigger this hot reload experience is either by using the CHAP signal, right? You can signal your container or your normal process if you're not using containers, or just send the proper request to the HTTP endpoint that you have to enable for that. It's not enabled by default for security reasons. So you can trust that your agent is going to be restarted. If the configuration, it doesn't work, you see a bad configuration, the behavior is like the old configuration that was working is going to be, it was going to run with it again as a failover mechanism. And hot reload today is available on Linux, Windows, macOS. I think that there's a small catch on Windows that is being fixed right now, but it's formally supported. So hot reload is there. That is something that you might not use every day, but when you need it, you have it. Now let's talk about this new concept of processors. This is just exists in V2, actually exists in V2.1, right? When I say V2, is the latest version of V2 series. As I said at the beginning, as an old architecture and very high level, we have an input, we have an engine, and then we have the output, okay? So you might say, oh, the input is collecting data and the output is delivering data. So everything that is data transformations happens here in the middle on that little engine. And the highlight of processors of why do exist is because we wanted to take this experience of filtering to the real next level. Also, if you're managing a lot of filters, it gets performance penalties, right? And for operators, managing this stuff gets really complex sometimes because you have to use the routing mechanism that we have in a plain config file that is really hard to understand when it gets serious around adding a lot of logic inside the pipeline. So if I can explain how this processor works, I'm going to use this diagram. Imagine that here we have the data pipeline. What happening inside is like we're going to see from left to right. In the left, we have an input or a source that receives data or collects data. What processor does is that as soon as the data is collected, the processor will have its own processor unit, its own rules, where they're going to modify the data that has been collected in the previous stage. Then it's going to generate a chunk with events, and then those events are going to be routed to a certain destination, right? But if you don't have processors, the data just will flow to the output destination. But now you have the ability to attach a processor to the output, where here you can modify the data and apply other type of logic for processing before delivering the data to that output. I know you might think, oh, why do I need to do two processors if I can do it just in one? Actually, just in one, that was the way that filters were working, but I'm going to give you a really good reasons for that. One of them is like you collect the data, you go to processors, and you generate a couple of events, couple of chunks with events. But in reality, and if you go to production, I don't know if in your company or if you are evaluating solutions, you might have two backends, and we have, as Calyptia and companies send data to at least two places for sure, right? And there's a couple of use cases. For example, we have cases where they are a big Splunk shop, right? And they send all the data to Splunk, and those that got really, really expensive. Then they analyzed that not all data that was sent to Splunk was relevant for them. For example, if you have a record with 10 keys, I don't know, 10 keys with 10 values, and you are just analyzing 2 keys of them, why you are using extra space storing all the remaining part of the log might not be relevant. So a common strategy that we are seeing at Calyptia with our customers is like they send the data to 2 places, right? Usually the first place is the cheapest storage possible. Today they found that is S3, Amazon S3. They send all the data to S3. But then they also send that same data to Splunk. But before the data hits Splunk, what they do is to touch a processor where they can say, oh, I'm going to remove this number of keys from this record before the data hits the backend. And this is a real strategy. Here is where you can optimize in cost, but also have a better logic on how to approach this divide and conquer to solve the data problem from collecting data from multiple inputs, multiple sources, and where you need to manage a different strategy and optimizations for cost savings and also performance. So keep this in mind. Now you can do processing in the input and the output. And now, is this deprecating filters? The answer is no. But also the processors can deploy filters. So we designed this interface in a way that you can attach your current filters as a processor in a very, very easy way. Now, looking at an example and a configuration format, and this is a YAML. Here I went a bit beyond the, maybe I can stop here and use this selector. For example, we have here, we have the pipeline that defines the inputs. Inputs means where I'm collecting data from. And I have 2 collectors. One of them is TEL, which is an internal plugin to read files from the file system, while I have other here that is called Node Exporter Metrics. I'm going to do a pause. Node Exporter Metrics is a built-in plugin that we have to collect operating system metrics like the Node Exporter Prometheus project. We collect the same metrics, same levels, same descriptions, so we can have a more unified experience from metrics collection perspective. And also we have a version for Windows, and the new one for macOS is being built. Okay. Okay, so we have the inputs. Here we are collecting data from files. Then we have all the properties, configurations. But as soon as we collect data, we are attaching a processor to it. And processors can be applied, processor for logs, processor for metrics, or processors for traces. In this example, we are processing for logs. And we are using the Lua processor. The Lua processor is the same as the Lua scripting engine that we have. This allows us to write custom logic into the configuration. And this is I want to write a script to modify my data. You do it on this way, right? So you create a processor, you define the function. This is just how the Lua API works for us in Fluent Bit. We define a new record, we attach a new key that is called tag with the tag from the chunk, and then just we return the data that is expected by design. On this process, we are not running a filter that runs on all the input plugins. This processor is just running in this unit of log. And same as I have Lua here, I can have 1, I can have 2, 3, and all of them will run from top to bottom. So you can chain and attach one after each other. And that gives you a really good experience. Second, we have other collector that is called Node Exporter Metrics, that, as I said, it collects metrics from the file system, metrics from the operating system, from the host, and this could be memory, network, CPU usage in global, per core, processes that are running there in the system, plus many, many others. And the processor that we are attaching here is like, since we are collecting metrics and we have a native schema for metrics, we are adding a new label that is called, so we are running the processor that is called labels, and we are inserting as a label or dimension, upsert means update or insert, a label called color with a value blue. The hash is an internal value that can be used to modify an internal representation. I'm not going to give those details right now, but the same thing experience that we got with logs, we are extended with metrics and traces too. So that means, yes, if you are running an agent, a Fluent Bit agent on your VM, you can start doing all this processing right there in a very efficient, a fast way. And I'm happy to say that we have been very careful about performance, and this is the cheapest way in terms of resources to do data transformation. So, and just to summarize on processors, are we deprecating filters? The answer is no. Can you reuse the filters? Yes. Should you move your filters to processors? Yes, please do it. You will get a better experience, and make sure just your plugin is running a separate thread, and you will get the best experience, because the best outcome will be better performance and a very optimized way, because hey, nobody's running a machine or a VM with just one single core, right? If you have multiple cores, you can optimize and use them. Let's go back to now to Kubernetes logging. We have done a lot of optimizations on how we solve logging in Kubernetes environments. And I think that it's good to do a quick walkthrough of how this works internally. As you know, Kubernetes is a cluster of computers, and logically, some of them has different roles. We have one that is a master that orchestrate, how the application run inside the cluster, and then we have the nodes that runs the application. So master just orchestrate and said, this application is going to be run on XY node, or I'm going to make 5 replicas of that application in these nodes. A simple container or inside a pod can generate 100, if not thousands of messages like this, right? Imagine we are in this scenario, right? You don't want to SSH into a node or inspect the pod just to see what's going on. But applications generate a ton of information. And that information, usually by default in most of Kubernetes environments, goes to the file system, right? So the way that it works is the application prints a message, a printf or a print. That message, instead of going to, or it goes to the standard output, but instead of being print on the screen, is internally redirected by the container engine and trapped and read into the file system in a file. But the message is not a raw message. Actually, that message gets encapsulated in a JSON message. So as you can see here, when we have the file, one single line that was an HTTP request gets encapsulated in a log key with a string and with a timestamp. But you will notice that the content inside log A is escaped, right? Because it's a JSON message. And now you might guess, oh, doing data analysis over this might be problematic because I need to collect the data from the nodes for the pods, plus decoding this information back. Yes, it adds some complexity. Also, it's really important that you can have the concept of context, right? It's not sufficient just to have one log message. You need to know where it's coming from, any relevant information, metadata, which pods come from, and so on. So this information exists in the master API server. But as I said before, hey, your nodes are here. So you have one here in the pod, in the node, while other lives here in the API server. And the way that we solve this problem is like you have this information, but if you think about mixing the master API information that you have for that pod, for the logs from that application, plus the one that you know inside the node, those 3 lines become something like this, where you have Kubernetes enrichment, pod name, namespace, annotations, and a bunch of information that is relevant, but maybe you don't need all of them. And the way that it works is the following. You deploy Fluent Bit as a daemon set inside your cluster, right? It's just one more pod, that's it. But the difference is that this special pod has access to all the logs from all the pods that lives in the file system. And Fluent Bit collects the data from your pods, it goes to the API server, extracts the metadata for your pod, and gives you a unified message with all the relevant information so you can solve the initial problem of data analysis. Now, when doing this, you might say, oh, we are always talking to the API server. Yeah, it's just once per pod, right? Because we manage a cache of the metadata and we have a TTL, I think 1 hour, 2 hours. So we are not saturating the API server. But also we integrated a way to collect the data, the metadata from the kubelet. Kubelet is a service that runs inside your node that also has a replica of that information. So there's different ways to optimize the data collection, but Fluent Bit can adapt to the two mechanisms that exist. And this is a general overview. So when you collect the data and Fluent Bit, merge all the metadata plus the data log, the data log, it can send it to one or multiple destinations that you have in, you need to use it or to perform a data analysis. And now going back to a quick walkthrough of the experience that we want to bring to Fluent Bit as a telemetry agent. Today is logs, metrics, and traces. Also, we're implementing some eBPF things that we're going to launch next year. So please stay tuned. For now, we can say that Fluent Bit in a nutshell allows you to convert unstructured data to structured data. It can do processing, filtering. This is all for logs. But in the metrics space, we are fully compatible with Prometheus, Open Metrics, and also the Open Telemetry protocol. That means that we can collect metrics or convert logs to metrics. There's another webinar that is recorded by Calyptia where we're explaining how that works. It's really interesting. I invite you to watch it. And the moment that we collect metrics, also we can export those metrics back to a different formats, to Prometheus, Splunk, InfluxDB. One example will be a scrape. We have a scraper in Fluent Bit. We can scrape Prometheus metrics and send them out as remote write or send them out as Open Telemetry metrics, right? Whatever you have deployed in your environment, we can do all these conversion layers. Now, from the Prometheus ecosystem and from metrics collection, as I mentioned earlier, we have a Prometheus scraper where we can go extract information. We can extract information from the operating system. It runs on Linux, macOS, and Windows. And for destination endpoints, we can expose those metrics using the Prometheus exporter mechanism, which exists in Fluent Bit, or just by doing a remote write. Just to tell you that all these implementations has been written by hand in C language, so they're really, really efficient. And in the Open Telemetry world, your Open Telemetry is a protocol that provide schemas for logs, metrics, and traces. We know Fluent Bit is fully compatible with Open Telemetry. And as I said, same as we support, Syslog was created 40 years ago, and we support it today. We are embracing Open Telemetry, and the goal is that we can have the best experience as a telemetry agent in the market for the enterprise and for infrastructure software. From a developer experience, you can write your own plugins in filters, for example, or processors in Lua. You can write your input and output plugins in Go. And also we announced the new Wasm interface. Now, the good thing about Wasm or WebAssembly, if you might be familiar, is a technology was created originally for the browser, right? In a way that I can write a program in Python or maybe Node or Rust and making sure that I can run in my browser. But short after, this technology has been moving to the back end, to the server side. And we always wanted to experiment how we can improve the experience for developers in Fluent Bit. And because people wanted to have full control on being able to modify data pipelines. Because, hey, nobody wants to write plugins in C except us, maintainers, and a lot of companies, right? But we want to simplify the experience because your goal is not to write plugins, your goal to solve your specific use case. And so how we can come up with the best thing of two worlds, a very fast and efficient telemetry agent, but with a high level developer's experience. And with Wasm, now you can write your own plugins in Go, in Rust, or any other language that can generate a Wasm bytecode. This is a pretty new interface. We are shipping more examples, more documentations around it. So if you just want to jump and try it out, please feel free to do it. And yeah, we're really excited about all these changes because if we look backwards where Fluent Bit started as a telemetry agent for logs on embedded Linux, today has taken over the world. And we want to continue embracing our community and making sure that we deliver the best experience possible. This is a Golang plugin. If you are a Go developer, you might understand what's happening in this little function. This can be composed as a module, then you can load it as a Wasm file. We just need to convert it with TinyGo, which is a compiler, and you're ready to go. So, and then this generate one file, and that file you can load in the configuration, and your plugin will be ready to be used. I'm not going to go to the details of the code, but here we're getting is like, hey, getting all the data that's coming from an original record, which is message pack in our case. We convert to native format in Golang. Then we are creating another message to the object, attaching the timestamp, the tag, the original message, converting back to route bytes, and just exiting. So this plugin in Go is pretty simple. Our goal is also to keep polishing the interface, so our developers has to write less code so they can iterate faster in the developer experience for data pipelines. And as of today, we are in total, Fluent Bit is everywhere. We achieved 10.7 billion downloads, which is great. We never thought that this project will be in the stage that is today. So we have a huge responsibility, and I'm going to talk about a Fluent Bit project creator. I think that the moment that I said we're going to start a company with my co-founder, with Anurag, the first investment will be to hire more maintainers, put more gas and gasoline on this project, because this will drive the future. Fluent Bit is not just one more telemetry agent. I think part of our story is that we have been redefining how telemetry data collection and processing will happen in the future, which is different. And I think we're happy to be in this journey. And so if you are a Fluent Bit user, thanks for trust in this project, because without you, there's no project. I think community matters.